Can I calculate the slope at a point? The learning target for today is I can calculate the instantaneous rate of change, IROC, at a specific point using limits and the average rate of change, AROC. So before we get started, again, we want to go over the questions you want to know for the quiz at the end of this video. Number 1, what is ARC, the average rate of change? What is IRC, instantaneous rate of change? What's similar and different between ARC and IRC formula? So there's going to be two formulas of what's similar and what's different. Why can't you just plug in 0 into the ARC or IRC formula? When do you plug in x into the IROC formula? Calculate the instantaneous rate of change given the function f of x equals 3x plus 2 at the point x equals 2. So these are the questions to know for the quiz, and throughout the video, the answers to the questions are given. Except for this last one, what you have is an example that looks like it, except we changed a little bit of it. Alright, so in your math notes, let's go ahead and begin. The average rate of change, AROC, that's kind of the shorthand way to write it, of f is actually this, f of x plus h minus f of x all over h. And then the instantaneous rate of change, IROC of f, is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, first off, where does this all come from and what does that all mean? So as a reminder, when we talked about the average rate of change and the secant line, as a reminder, the secant line was the line that connects 2 points on any curve or graph, and the average rate of change was the slope of the secant line, so like the rise over run. And we talked a bit about the slope, change in y over change in x, and the various different ways that we wrote the slope. This right here is the difference quotient, and we talked about why the difference quotient was important because we were able to manipulate and to change what h was in our formula. And if you remember, h was the horizontal distance between the first point and the second point. We were basically able to make h very, very small and kind of approach this first point when we're trying to figure out the instant rate of change. So that's why this formula was important. But take a look. The difference quotient is the average rate of change formula. So this actually comes from that. So what is the average rate of change? The average rate of change is basically the slope of the secant line. This right here is the slope of the secant line. This is change of y over change of x. And again, let me go back to that. Change in y over change in x, all of these three formulas represent that. Now the instantaneous rate of change is when we're making h very, very small. See, h is approaching 0 and we use a limit. Now one of the common questions basically is, why can't you just plug in 0 for h? Like if we make h 0, that's going to be the smallest that h can be, the smallest number. That's not negative, of course. The smallest h that it could be, and then virtually we'll get our instant rate of change. Now the reason why we can't plug in h equals 0 is because of this. And by the way, this is a reminder of what we're doing when we're kind of manipulating h. What we did is we went ahead in this problem, we had our distance formula, and we created our 2 points, right? When t equals 4 seconds and t equals 4 plus h seconds, right? And this was from a previous video. We went through the arithmetic, we did our change in y over change in x, and we basically came up with an average rate of change formula that had h in it. And as a reminder, remember we're manipulating h. See, in this scenario, h was 0.1. In this scenario, h was 0.01. And we're making h very, very tiny so that we can figure out what is the instant rate of change. Like at exactly 4 seconds, how fast is the car going? Now this one was making h really, really small from the right of 4. And this was making h really, really small from the left of 4. And that's why on this side it was negative. So that was us manipulating and making h really small. And a lot of us are thinking, well, why can't we just make h 0? That way we'll get the instant rate of change of the car at 4 seconds. We'll get the answer instead of all these approximations. Now, why can't you make h 0 into our formulas? Here's the reason. So remember, you can't divide by 0. If you try this out in a calculator or even on your phone, you're going to get an error. Again, you can't divide by 0, and there's many explanations to that, many videos. Feel free to reach out if you want to talk about this in the office hours. But basically, why you can't simply plug in h for 0 into these two formulas is because you can't mathematically. It's not possible. Anything divided by 0 does not exist. So that's why, in order to get the instantaneous rate of change of the car, we use the limit as h approaches 0. And then we'll be able to find out the instant rate of change with a limit. And that's when we get rid of h being in the denominator position. Then we could go ahead and plug in whatever h we want. So you'll take a look at that later on in this video. And then again, before we move on from the slide, please pay attention to what's different between the average rate of change formula and the instantaneous rate of change formula. Again, think about what's the same, what's different. You want to go ahead and make sure you have an idea in your head for the quiz. Okay, let's go ahead and jump into our first example on using the instantaneous rate of change formula. So again, everybody, this is going to tell us what is the instant rate of change, like at that particular instant. For example, let's say if this was seconds, at x equals 1 second, what would be, and if we say f of x is a car's velocity, it would be exactly at 1 second, what would be the car's velocity? Like again, as you're driving and you're looking at the speedometer, it's not going to be an average rate of change anymore. It's going to be an instant. So let's go ahead. So step 1, in order to find the instantaneous rate of change, make sure that you have the instantaneous rate of change formula right in front of you. This was right now given to you. And we talked a bit about why our h is approaching 0 and why we have a limit. Now the next thing, notice how these two right here are color-coded? It's because we're going to go ahead and plug in. So first we need what is f of x plus h, and then what is f of x. We're going to go ahead and go to the side and figure this out. Well, the cool thing is we already know what f of x is. Take a look. F of x is just 3x plus 2. Great, so we have one component. We still need this one. So what is f of x plus h? What you do is this x plus h is going to be substituted in for this x. Notice how instead of x, I put x plus h. And again, we're looking at this formula. In parentheses is what we plugged in. After you plug in, what we did right here is you distributed the 3 into the x and into the h like so. So this is what f of x is, and this right here is what f of x plus h is. So now that we have our scratch work ready, we're going to go ahead and substitute what these are in our next step. Notice we went ahead and substituted it. And again, see this part went in right here for f of x plus h, and the green part right here replaced what f of x was. Okay? And again, we're going to continue this mathematics until we hit the point that we can plug in h equals 0. And we will be allowed to do that once the h in the denominator position is gone. Because again, remember, we can't divide by 0. So we're going to have to do some math to get rid of that h there in the denominator position. The next step is let's go ahead and distribute this minus sign so we could cancel out some stuff. See, this became negative 3x, and then this minus distributed in here and became a minus 2. Now what's really, really great about this right now is things are going to cancel out. So now this plus 2 cancels out with minus 2. 3x minus 3x, well, that also cancels out. Essentially, what you're left over with is 3h over h, and also your limit. So once we have our 3h over h divided by h cancels out. H divided by h is virtually 1, And then 3 times 1 is just 3. So that's why we got the limit as h approaches 0 is equal to 3. Well, what is the limit as h approaches 0? Well, there's no h here to plug into. So no matter what h is, we're always going to get an output of 3. Our answer here is just going to be 3 in this scenario. All right. So that's example 1. And again, you want to make sure that you pause this video and just work through the steps. Take your time learning the steps of this. And again, prepare any questions that you might have about this in office hours. Notice how in this scenario, we're not creating 2 points anymore. What we're doing is using the exact formula now to shorten our calculations. Example 2. Now we're going to go ahead and calculate the instantaneous rate of change given the function f of x equals x squared, and now we're going to take a look at the point x equals 2. So step 1, please make sure that you have your instantaneous rate of change formula out in front of you. Step 2, be aware that you can't just plug in h equals 0 here because you can't divide by 0. The next thing is make sure that you have your scratch work and you're ready to determine what f of x is and what f of x plus h is. Again, f of x is right here for us, which is nice. Great, f of x equals x squared. But what is f of x plus h? So this one's going to be a little bit different from the last one because we have that squared going on. So we get something that looks like this. If we plug in x plus h in for x, we're going to get x plus h squared. Now, if you remember from the previous videos, when we did x plus h or like 5 plus h squared, you had to use either rainbow method or you could use the box method to multiply these out. So remember, x plus h squared is the same thing as saying x plus h times x plus h. Again, exclamations, that's super important. You could either use the rainbow method. When you do this, x times x squared, x times it, x times h, xh. X times h is again xh. H times h is x squared. Xh plus xh is 2xh. And that's how we get it with rainbow method. Now, box method is going to be the same thing, except you're using it like this. And you go x times h is xh. H times h is x squared, x times x squared, and then h times x is xh. With the box method, what's nice is that this diagonal, these two, will add up, and that's where we get the 2xh. So again, where did this come from? You want to make sure that you pause the video and take a look back at the rainbow method or the box method as to how we got x plus h for this scenario here. Now that we have f of x and f of x plus h, let's go in and substitute as we did before. So again, we're just getting some practice on using this formula. Great. So we substituted for x plus h, and again, we did our side work, and we substituted for f of x. So now, this minus, these brackets now, we could go ahead and drop them because we don't have to distribute this minus sign because there's not much more to distribute. That's just going to be minus x squared. Okay. Next, x squared minus x squared. This will cancel out. You're going to be left over with 2xh plus h squared all over h. Okay, if you remember from a previous video, there's a way to simplify this expression right here. Notice that right here on the top, we have a common multiple. The common multiple right here is h. This one has one h. This one right here, this term has two h's, and at the bottom we have h. That means we can pull out an h from the top and cancel. Notice how I did that right here. I pulled out an h from the top expression. And remember, this is kind of like backwards distribution. We call this method factoring out the h, by the way. But once you've pulled out the h right here, what you can do is you cancel out the h's, and then you're just left over with 2x plus h, and we still have to bring our limit expression. Now I'm taking a look at my notes here. Question 5 was, when do you plug in x into the instant rate of change formula? So the answer to that question will come up very soon. But the answer to that question basically is, well, okay, we have the limit as x approaches 0 of 2x plus h. Now that we've gotten rid of the h in the denominator position, we can now plug in 0 for h. So we're going to go ahead and do that right now. Let's plug in 0 for h. So we have 2x plus 0. What you have now is 2x. Again, we were allowed to plug in 0 for h because we got rid of h in the denominator position. The last thing that we're going to do is we're going to go ahead and plug in our x. So that's the answer to question 5 is when do you plug in x into the instantaneous rate of change formula? It's actually at the very last step once you've simplified everything. So again, make sure you pause your video. Make sure that you know the answer to that question. When do you plug in x into the instantaneous rate of change formula? It's at the very end once you simplify everything and after you plugged in h when applicable. So it says x is 2. So we're going to go ahead and plug in for x equals 2 right here. So 2 times 2 is 4. So now, if this was the car formula, or if this was the car problem, and they said that the instant rate of change is 4, and we could imagine like 4 feet per second, that would be that at x equals, let's say, 2 seconds, the instantaneous rate of change, or the car's speed, is going to be 4 feet per second exactly at 2 seconds. That means that's exactly the speed I'm going at 2 seconds. The last thing we're going to go through, and remember question 6 is you're going to have to calculate the instantaneous rate of change of f of x equals 3x plus 2 at the point x equals 2 for the quiz. That's more like example 1. But the last thing we're going to do is we're going to go ahead and take a look at the graph of what happened. So again, this right here is arithmetic. You want to make sure that you connect the arithmetic work to the actual graph of what's happening. So we go ahead and click our Desmos. This right here was the function f of x equals x squared. This was just the example that we did right now. Now our h, what we want is we want h to be 0 because look at this, everybody. Right now what you have is a secant line. Remember, a secant line connects 2 points on your curve, which is the green part right here. This green part is your f of x equals x squared. What we want is for h to be 0, because when h equals 0, that's when the secant line becomes your tangent line, and when h equals 0, that's when the points are almost like they're on top of each other, right? That's when they're like on top of each other. Now this line, notice that it's kind of disappearing, right? The line disappears exactly when h equals 0 for the reason that I mentioned. If you were to stick this into your calculator, you would get an error because you can't divide by 0. See, and this is our expression. When our h is 0, it's just not possible. But in our expression, we got rid of h and we were able to find the equation of that tangent line. So this is almost to what I want. So you want to imagine that it's exactly at that point, and we got 4. So right here, instantaneous rate of change is 4. And again, if you imagine a car traveling at t equals 2 seconds or x equals 2 seconds, the instantaneous rate of change would be 4 feet per second at that instance. That is how fast I'm going in my car if you look at the speedometer. So again, what is this problem doing? The limit, right? H is the limit. The limit as h is approaching 0, and as h is approaching 0, that secant line became my tangent line. And again, we used arithmetic to get rid of h in that second problem, and we were able to plug in h equals 0 into that. So that's a graphical experience of what we just did. And again, you want to take notes, jot down any questions you have about what we've been doing. And I believe we went through all the questions that you need to know for the quiz. And again, if you have any questions, make sure you drop by the office hours. Please have some example problems that you want to work on. I'll see